This video is presented to you by Physics for Students.
In this video, we are going to look into two aspects of the subject. First, let us understand how this equation can be proved using simple mathematical calculations. Simple means really simple, without any complications. In the second part, we are going to find out who the original hero is, the creator behind this famous equation. We are also going to take into account researches which have taken place to find out the person who first laid the foundation stone of this formula. So, let us get going. We have seen this more than 1,000 times. We have thought about this maybe even more than that. We loved and appreciated and stared at this equation in awe for generations. Yet, when it comes to understanding the intricacies of this, we take a step back. Why? Because it is mathematics. Because it is relativity. Because it is Einstein. Perhaps this is one of the most glorious equations which mankind has ever produced. It's difficult to separate the enormous legacy of E is equal to mc2 from Einstein's legacy as a whole. After all, the equation grew directly out of Einstein's work on special relativity, which is a subset of what most consider his greatest achievement, the theory of general relativity. Most of the proofs that we see on the internet or YouTube use either the Lorentz factor or calculus to derive it. Today, we are going to use the simplest possible proof through which anyone, even with a non-mathematical background, can understand. So, what is it?
First, what we are going to do is that we are going to see that why we cannot travel faster than the speed of light. As per the theory of special relativity, we know that a moving body gains mass. Now, when I say that a moving body gains mass, it means that we are not going to see into the mathematical derivation how and where and into what intricacies a moving body gains mass. We are just going to assume that it gains a mass. First, let us assume that a body or a car is moving at 50 kilometers per hour. It moves in this direction and it hits the wall. When it hits the wall, it creates a kind of an impact, which is this. The same car is now moving at 10 kilometers per hour in this direction and it hits the wall and it creates a kind of an impact. And you can see that the 10 kilometers per hour moving car creates a lesser impact compared to that of the 50 kilometers per hour moving car. In the third example, what we do is that we take a truck, which is weighing around 10 ton of materials. It moves at the same 50 kilometers per hour in this direction and it hits the same wall. So what it does, it creates a higher and the highest impact compared to those three cases. And this is what? So a car which is moving at 50 kilometers per hour creates an impact which is higher compared to the same car which is moving at 10 kilometers per hour, which creates a lesser impact. And the same speed, that is 50 kilometers per hour, gained by a truck which is moving and has got an enormous mass of 10 tons, hit the same wall and it creates the highest impact. So what do we gain from all those three cases? What we see is that the energy what is generated is there and the increase in speed can be done, but there cannot be any increase in mass. Whereas the energy which is generated can be increasing in mass, that is the final case of our truck which is weighing around 10 tons, but there is no increase in speed. It is moving at 50 kilometers per hour. Now say for example we have got a body, let us say for example our car, which is moving close to the velocity of light c. Here is this car, and what we are doing is that we are adding a little bit of petrol, which is at the initial stage it is 10 liters. Okay, now suppose a car is moving at a near velocity of c, which is the speed of light, and as per the special theory of relativity we have seen that it follows that the mass of an object increases when it moves close to the speed of light. Now, I would like to emphasize on one fact that we should understand that this is not a phenomena which is observed in our daily life. It is not that a person is moving or a car or an aeroplane is speeding at the speed, that means it is gaining a mass. No. So let us not be in the misconception that anything which moves fast gains mass. No, at a lower speed the increment is infinitesimal. So it has to be at the speed of light. Now this car, we add a little bit of more petrol and it gains mass. We make it 20 liter, we make it 30 liter, the mass increases further. We make it 50 liter, the mass increases further, and then it increases up to infinity. That is when it is closer to moving at the speed of light. So here is an example when the car is moving near to the velocity of light. We are adding petrol that is increasing in the mass increases and it goes up to infinity. Now say for example we take the same case. Now what I'm trying to tell you over here is that this increases close to the speed of light. As it approaches, the mass increases. So for example the first case, 99.9%, it gets a mass of say 22.36. In the second case it increases to 99.99%. We see that the mass increases 70.71. It increases further to 99.999% of the speed of light. It goes to 223.36. And when it comes absolutely close to the velocity or speed of light, it increases to infinity. Now the thing is that if you see in each cases the force which is applied here is bigger than this, right, when it is 99.999%, and it is further increasing to 99.999%, and it increases further when it moves to infinity. So the question which arises is that where will we get this infinite amount of energy or force when the car is moving close to the velocity of light, that is c? It is something you can imagine, like you are asked to climb a mountain and every 10 feet you are given a large rock, right? So you move every 10 feet, you are given a larger rock. So you would require more strength and more strength to move. Further 10 feet, you get even a heavier rock. So in this case, what happens is that you cannot move further. So the question rises from this kind of an analogy is that how and from where you gain this infinite amount of force or energy so that the car or the body accelerates and becomes infinite in terms of mass. So the Newton's equation, if you can take F equals to ma here, F becomes infinite, and the question rises that how can we get the infinite force? This is a kind of a simple analogy just to demonstrate that this is the reason that we cannot gain or cannot move faster than the speed of light. Just a note that in case of the recent researches that we see, the Large Hadron Collider or the LHC, where the particle has been accelerated closest to the speed of light, is this. Right, it is 99.1234567%, 9999999% of the speed of light. So we can add more speed, but we are only going to get the nines, more 9, 9, 9, and further to the right hand side, and that is that we cannot reach the speed of light. Precisely, we can never reach the speed of light in vacuum. That is the ultimate speed or the limit we have achieved for massive particles, for that is the speed of all massless particles. So this is a kind of a, I would say a nice example that because we are unable to get this force which is becoming infinite, it proves that we cannot get close to the speed of light. Okay. As we have seen in the first that we are going to look forward for the derivation, but here there is a note of caution which I would like to draw to the viewers. The thing is that I would like to make a point about this derivation is that this is for the amateurs, right? And it is not rigorous. I mean to say it is not an absolute rigorous proof. So you can see that I have laid down several points. The basic idea is just to give the amateurs a framework on which it works. I have deliberately avoided using Lorentz transformation and calculus, which is very common, which is the right kind of a proof which method in which we do, and other mathematics, because that is a very basic thing we are going to do. We are using the method which is called handling units and Newtonian mechanics like velocity, force, momentum, impetus and energy. That's it. We are not going to look much more into the details. We have just used Newtonian mechanics to understand. My basic objective is that let the young people learn from this and becomes curious, and they can go further and further and deep into the real mathematical derivation of E equals to mc squared. So this is a note which is very important, because the viewers might question me that how and where, and this is not right, this is not wrong. So this is just because we are handling units and we are using no nomenclature in deriving the formula. It is just a basic intuitive approach just to make people understand how this works. Now say for example we take a body which is moving close to the speed of light, that is c. We know from Newtonian mechanics momentum equals to mass times velocity, and in mathematical way we can write rho equals to mv. We also know that force equals to mass times acceleration, which can be written as this, which we all know, F equals to ma. We also know what is an impulse. Impulse applied to an object produces a change in momentum. So impulse equals to force multiplied by the final time minus the initial time, which can be written as this, I equals to F multiplied by delta t, where delta t denotes the change in time. And we also know that the work done equals to force multiplied by distance. So what will happen if a constant force acts on a body that travels close to the speed of light? Now here you see that we have written, I have written impulse equal to force, which is from the previous one. So we write this, and we know that impulse is something we encounter in our daily life. For example, when we hit a ball or we punch a bag, we use impulse. Since impulse is a measure of how much the momentum changes as a result of a force acting on it for a brief period of time, we can write the formula of impulse as this. Right? So I have just elaborated the delta p part, which is the final minus the initial. So impulse and momentum are directly related, and this is how it happens. So you see on the right hand side, what I have done is that I've put forward F equals to ma, and I have just put a little bit of more definition of acceleration, which is the change in velocity by change in time. And we can see that if I take F delta t equals to mv, and this part is the impulse and this is the change in momentum, right? So this is just kind of a a basic Newtonian mechanics that is there. So it is important for us to understand this. Now if I take delta t and if I define it as a unit time, what we get equals to F equals to mass times change in momentum. Now, we all know that energy is the capacity for doing work. It can be any kind of a work. It can be, say, for example, lifting a book, walking. In fact, what I'm doing right now, talking and making people understand, that is also a kind of energy, anything. So the increase in energy is due to the force which acts on the body. So what we can do is that we can write this, energy equal to force multiplied by the distance traveled. Say for example we are taking the velocity of light or the body which is moving, so it is the distance traveled, right? And what is the distance traveled? We know from the basic Newton mechanics, it is distance equal to velocity multiplied by time. So what is the distance that the body travels? Now we know that here in unit time where t equals to 1, the body travels, which is more or less close to the speed of light, so we put it as c multiplied by time. Now as you can see that we also know that as our body, in our case the body moves almost close to the speed of light, so it is the speed of light multiplied by time. So we can just as I have been telling that we are handling units, so we can just use the first equation and substitute the value of c instead of distance traveled. So we get force multiplied by c equals to energy. Now we take the equation further. Energy equals to force multiplied by c, which is our first equation. And then what we do is that we know force equals to mass times c. Why? Because the body is accelerating at the speed of light. So we substitute acceleration instead of c, and we get the second equation. And here we just multiplied energy equals to mass multiplied by c times c. So substituting equation 2 into 1, we get this. Right. Now please note that here we assume that the body moves close to c and would not be able to explain the general case between mass and energy. Also, the viewers are requested to take a note that we just handled units and used this method. If a student is given a set of definition and taught the rules, which I believe the physical quantities, whatever units you choose it can be expressed in any other quantities. This is basically a very basic and a kind of a very intuitive understanding of the equation equals to mc squared. And now we are ready to move to the second part of the video, which is much more interesting. Amongst the many ineffaceable names which shines in the history of physics, amongst Einstein, Poincaré, Hendrik Anton Lorentz, one name remains hidden, yet it creates a permanent impact. An unknown Austrian physicist who first made a serious attempt to create a connection between mass and energy of radiation. Friedrich Hasenöhrl, born in Vienna, was an Austrian physicist. His father was a lawyer and mother coming from an aristocratic family. Completing his basic education, he went to the University of Vienna and studied science under the savant tutelage of Joseph Stephan and Ludwig Boltzmann. If I take the words of Erwin Schrödinger, no other person has had a stronger influence on me than Friedrich Hasenöhrl, except perhaps my father. Hasenöhrl was the cause for me that I turned to theoretical physics. Hasenöhrl's lively character and friendliness attracted many students, like both senior and junior, and he took part in many winter sports. Between 1904 and 1905, he published 3 papers primarily known as H1, H2 and H3, and this is entitled as On the Theory of Radiation in Moving Bodies. And this is the original German title and a copy from Hasenöhrl's paper. Now, it was related to the mass equivalent of black body radiation in a moving cavity. The latter 2 papers won him this prize. So as you can see that we are approaching the second part of the video, in which we are going to learn and we are going to look more into details of Friedrich Hasenöhrl, who can be called as the creator and the precursor of Einstein's equation. He was working within the limits of ether theory, and as we will see that his results were replaced by Einstein. Hasenöhrl worked on 2 blackbody radiators, A and B, which is placed inside a cavity with reflecting walls, which is called the length D. Now when t equals to 0, that is the time equals to 0, the radiating caps start emitting photons in the direction of motion, which is a plus or positive, and opposite, which is negative. From the frame of reference of a moving observer, the plus and minus photons will be blue or red shifted and will be different reaction forces, and it will put different reaction forces on A and B. He performed what is called a Gedanken experiment. Well, Gedanken in German means thought. You can see that this kind of an experiment similar is carried on by the Albert Einstein also. So in German and in In general, in common terms, it is called a Gedanken experiment. This is basically the first foundation stone of the black body radiation and the energy which is emitted from photons. In his first paper, Friedrich Hasenöhrl arrived at this equals to 3 by 8 mc squared, which he later corrected to this. Now he has applied the concept of electromagnetic mass to a cavity filled with radiation, arguing that any kind of a thermal radiation provides such a body with an apparent increase in mass, right? Now, the researches that we find now supports this, right? And he had made the error, which is very difficult to find. The researcher says that why he made this error is really difficult to find. Now, Israeli physicist Max Jammer says what was probably the most publicized pre-relativistic declaration between inertia and energy was first made by Hasenöhrl. Renowned scientist and historian, the writer Mr. Abraham Pace, I have actually read many of his books, including Paul Dirac, The Man and His Work. You can read J. Robert Oppenheimer, A Life, Niels Bohr, Times, Oppenheimer Alive. A lot of books are there. I personally read the book Subtle is the Lord, okay, where he comments this. Before 1905, Hasenöhrl showed that kinetic energy of a cavity filled with radiation increases. It increases in such a way that the mass of the system appears to increase. Now, as you see that I have just quoted the lines of Abraham Pace, so Hasenöhrl's basic prediction and the experiments that he performed are in line with special theory of relativity, which later proved by Albert Einstein showed increase in mass. In spite of the incorrect results, he stated that black body radiation has a mass associated with its velocity. Hasenöhrl's incorrect results were replaced by Einstein. His thought experiments were, however, much brave and much courageous. As you can see, I have laid down the points that he was working within the limits of classical physics, so he really had no idea of relativity. His views were not covered by relativity. He did his best with the tools that were available during that time, and his analysis was restricted to the inertial mass of the black body radiation. So recent researches show that he was working with non-relativistic mechanics, hence he made this error. However, otherwise he could surely would have achieved 2 equals to mc square. Here I would like to show that acceleration of a black body radiation satisfies this. Now, the entire point of making this video is to make you understand that before to Einstein also, I won't say it is not Einstein, but before to Einstein, this gentleman actually laid the foundation of E equals to mc square and the energy mass equivalence principle. In a paper written in 2011 and again in 2013, American physicist Tony Rothman and Haverford College graduate Stephen Boughn re-examined this concept in further details. I have provided the link of the original paper in the description box. In case you want to read it, you can. The purpose of their research was to examine Hasenöhrl's experiment in the modern relativistic terms and see what he went wrong. And as you can read and we can see that they considered Hasenöhrl to be the contributor for E equals to mc square, which is a precursor to Einstein equation. In an interview to physicsworld.com, Tony Rothman told that he came across Hasenöhrl's name, but he never thought of looking into it. The duo presented an excellent paper which traced back to the motivation behind Einstein's E equals to mc squared. They finally concluded in their research paper the primary mistake that Hasenöhrl did in his first paper was that he did not consider the mass of the black body. Even after the black body radiation has a mass which is this m equals to 4 by 3 E by c square. Further, Hasenöhrl's second and third paper, which deals with accelerated cavity, concludes that the mass associated with blackbody radiation is this, which you can see at the bottom of your screen, which is consistent with special theory of relativity. If, as per the research of Rothman and Boughn, one concludes all components of the system, including the stresses of the cavity, the research suggests that the total mass and energy of the system is this, which would have led to the infamous equation E equals to mc squared. Culminating from the point of mass and energy ever since James Clerk Maxwell framed his theory, and then J.J. Thomson and other physicists dealt with what is called this. Poincaré and then Max Abraham agreed that an electron in motion will actually have a mass which is this. So existence with initial mass associated with electromagnetic energy were dealt previous to that with many. However, Poincaré and Abraham pointed as the motion of the electron which will have a mass like this. These were the results of what we call today as mass-energy relationship. In the classical arena, on the other hand, what Hasenöhrl did is that he generalized the scope of the investigation. So because he was working with ether theory, E equals to 3 by 4 mc squared was soon replaced by Einstein as this. So the whole point of my understanding, looking into the papers of Rothman and Steve Boughn, is that he is the person who, although incorrectly made an error, but this was basically the foundation stone of E equals to mc squared. You know, there is a book called Brilliant Blunders, if you can look into it, and it says that even great physicist makes blunders, it actually creates a foundation stone through which the further researches are made. As per the research report presented by Rothman and Boughn, Einstein simplified the equations using relativity. Now, here is something which I am going to tell you, that I am just taking or extracting papers of Rothman and Boughn just in order to show you, not to make you confused about the equation, but just to show you how Einstein simplified using relativity, considering the electromagnetic part, and what was the problem, or I won't say problem, what was the challenge that Hasenöhrl actually faced when he was working with this part. So considering a point mass that emits electromagnetic radiation in opposite direction, we consider a frame of reference, say whatever the laboratory where he was carrying the experiment. It carries an energy which is this, where he considered E sub I to be the initial energy and E sub F to be the final energy. So Einstein uses the relativistic Doppler shift to get this and get this. Now subtracting the first equation from the second, we get this. And you can see, so the above two equations, E prime minus E, which must be in kinetic energy, which gives to this, and which gives to further this. So this is how actually Einstein simplified using relativity itself. We get further into this, right? And now he takes the lowest order expansion and uses a square root of this, which gives to this. So this is just a kind of a the research that Rothman and Boughn actually took place, and they have shown that this is how Einstein arrived equal to E equals to delta mc squared. That is the point which Einstein made, simplifying and using relativity. On the other hand, before going into further, let us look into what Hasenöhrl actually did. Now this is a kind of a figure which we get, and he assumed c to be the absolute speed and c prime to be the relative speed. So by definition we get this, right? And you can see psi, and yeah, the angles are there, and so we get this. So c is the upstream velocity of light and v is the downstream velocity of light, and with a little bit of trigonometry we can, okay, this is something which we get from the figure, and using a little bit of trigonometry we can get this. So this is just to give you an understanding what Hasenöhrl did, considering the assumptions that c is the speed of light and c prime. Now, as you can see that I have avoided the further complications and further calculations, and with classical ether theory, which gives rise to this, and you can see that it gives rise to numerous calculations like the pressure and intensity. But however, this p underscore would be the cavity frame variables and the absolute speed of light. So this is what is, I won't say versus, but I would say what Einstein did and what was the way that Hasenöhrl did, and this was exactly the research that Tony Rothman and Steve Boughn carried, and I've just extracted few lines and few mathematical derivations from their paper. Now, Tony Rothman and Boughn concluded that E equals to mc squared is not a law of physics that can be indiscriminately used without referring to the intricate details of the system. However, their brilliant paper brought Hasenöhrl into the limelight. There are many doubts, controversies regarding the publication of the equation. As you can see, Albert Einstein published his paper in 1905 in Annalen der Physik, a few editions after Hasenöhrl. There are controversies that Einstein plagiarized this formula. In case Hasenöhrl had included the shell in his calculations, it would have been much more consistent, and the prefactor 4 by 3 would have been replaced by 1, which resulted into E equals to mc square. The question rises, did Einstein knew about Hasenöhrl's paper? Were they in touch with each other? There are different explanations for the result. Even Enrico Fermi argued that this is similar to the 4 by 3 problem of electromagnetic mass. Now, as you can see that in the first Solvay conference which was held, both Einstein, Hasenöhrl, and numerous other physicists went. Was there a conversation between Einstein and Hasenöhrl? Did Hasenöhrl ever explain to Einstein that he was going through a near about calculation or something like this? Well, the answers are not known. I can only say that the answer, my friend, is blowing in the wind. The answer is blowing in the wind. You can see in the first Solvay Congress, Hasenöhrl standing about 5 paces away from different scientists. However, Hasenöhrl's legacy was overshadowed by Einstein's supremacy. This is my humble effort after reading research papers and going through numerous scientific documents and papers to bring this unknown physicist into limelight. I hope you like this video. Thank you very much for watching.